Group6 Smart Power. I'm Jake Frank with Blonde Link, so my Higgins. So this project is about backup power for power outages. So what we want to achieve here is when we have critical loads, such as medical equipment or a refrigerator where we want your food to spoil, that we need to preserve power during outages. So what we've come up with here is a system where we have batteries that are recharged by a solar panel, and we have some software that will allow us to choose which loads are run for a given level of battery power remaining. And then, beyond that, we just had some additional switching circuitry and hardware to take care of that. So over here we can see like all these voltages and currents and such. And Vaughn knows a little bit more about this, so you can go ahead and talk about that.
Pretty much, this is battery voltage, AC utility voltage, and inverter voltage. And these lights are the loads, and basically the switches allows you to turn the loads off, on and off electronically. So, say for instance, load A is the flag, which stops, and then.
So like you are pressing the button, the flag it will be turned wrong?
Yeah, but also it can change depending on, say, the capacity remaining in the battery. Say, if none of the loads except load A will be on, if the capacity is real low. So that's load A. That will always run until basically the batteries are fully discharged. But as, say, the capacity goes down, other loads will turn on. And this is pretty much a simulation because in the time using these loads in that time, we couldn't discharge the batteries fully, so we have to simulate the discharge using this capacity usage slider. And then also it switches to this allows us to switch to the inverter. So now this is being ran by the inverter. So all these loads, and now you can actually see, say the current coming from the battery has risen to, it's dropping 2.5 amps into the circuit to be able to power those loads. This light is off because this light is hardwired. It's excluded from our system, so it's not being powered right now.
Is this a battery box?
Yes.
Like some batteries underneath of it?
So basically, to do the DC switching, we use MOSFETs. And this MOSFET, basically, we draw 4 volts and then it turns on, and if we move that, it turns off. We're actually drawing 5 volts, but then from basically that's hardwired into the line of the inverter, so it basically doesn't allow it to ground. And on the AC switching, we use triacs because they have bi-directional current. So it allows us to switch AC loads on or off, depending on, we have to send 5 volts, but we actually use an opto isolator circuit. It's really hard to see, but that allows basically the very expensive driver equipment not to be damaged, save in the case of a short or what have you.
So just briefly tell me the usage of your system, like what kind of situation it can
basically they'd be for home or business use. Obviously you'd scale the project accordingly where you're going to use it. We geared it more towards home use. If you have medical issues, you need any type of medical care that uses power, this will keep the power running when the power goes off, so you don't have any issues. Another thing is just home use lights, depending on what loads you want to control. If you need your cell phone on for emergencies, things like that. And then for businesses, obviously, to keep lights and certain things of emergency equipment running there as well.
How much it will cost for the total of this? Do you estimate this?
Estimated, well, solar panels are really expensive. The solar panel that we have is, I think, $400. And that's the main problem with, say, using solar panels for backup battery power is just the high cost of solar cells. But it's renewable energy, and every day the sun shines, so it always
just this
continues
morning,
to charge.
this solar panel charged our batteries up from all the testing we were doing last night. So I mean, it will work, and it is renewable, and it's definitely a step up from, like say, using a gas powered generator where you have the noise and you have to buy the gas and everything for it. So
And it can't, like a gas powered generator wouldn't be able to be inside.
Yeah,
So
that's
whereas-
true. Yeah, very nice. Thank you guys.